Welcome to Module F5 of the Clause Continuous Improvement Program, Quality at the Source and Standard Work Basics. In the last module, we talked about culture, scientific thinking, psychological safety, the behaviors that make improvement stick. This module brings those behaviors to the workbench. We're going to answer two very practical questions. First, where does quality actually get made? And what does it mean to build it in rather than inspect for it afterwards? And second, once you've found a good way of working, how do you make sure it survives? The next shift, the new starter, next month. The answers are two of the oldest and most powerful ideas in Lean: quality at the source and standard work. By the end, you'll know exactly what both mean and what they ask of you, personally, at your own workstation. Let's get into it. Here's what you'll take away from this module. First, quality at the source, the three commitments that define it. Never knowingly accept a defect, never make one, and never pass one on. Second, stop and fix. What Jidoka means, what an andon signal is, and why stopping the line when something's wrong is a strength, not a failure. Third, error proofing. Why good people still make mistakes, and how Yoke designs the work so that errors either can't happen or are caught instantly. And fourth, standard work basics. What a standard really is, why there's no improvement without one, and why the best standards are living documents owned by the people who do the work. 4 ideas, 1 theme. Build it right the first time, and make the right way the easiest way. Let's start with a question that sounds simple. Where does quality come from? A lot of people would say the quality department, but think about what the quality department actually does. It measures, audits, and reports on quality. By the time an inspector sees the product, the quality, good or bad, has already happened. Quality is made or lost at each workstation, in each step, by the person doing the work. That's you. In Module 4, we met the Shingo guiding principles, and one of them said exactly this: assure quality at the source, build it right the first time, and never knowingly pass on a defect. This module unpacks what that principle actually asks of us. And it starts by looking honestly at the old way of doing things and why it fails. Here's the hard truth about the old model. Inspection at the end doesn't create quality. It finds failures. Late. The traditional approach was simple: run production at full speed, inspect everything at the end, and sort the bad from the good. It feels safe, but look at what's really happening. Defects are found after all the value has been added. The material, the machine time, the labor are already spent. The feedback is slow. The process that caused the defect has kept running for hours or days, making more of them. And worst of all, it quietly tells operators that quality is someone else's job, the inspectors. Catching defects is not the same as preventing them. That difference is the whole subject of this module. There's a simple rule of thumb for what a defect costs, and it's worth carrying in your head. 1, 10, 100. Catch a problem at the station where it happens, and it costs about 1 unit. A moment to correct, a part swapped, done. Let it escape deeper into the plant, and the cost multiplies to something like 10. Now there's rework, sorting, tracing back through batches, maybe scrap. Let it reach the customer, and it's 100 or more. Returns, claims, expedited replacements, and damage to trust that doesn't show up on any invoice. The exact numbers vary, but the direction never does. The longer a defect survives, the more it costs. And remember from Module 2, defects and rework are one of the 8 wastes. Every escaped defect consumes capacity you could have used to make good product. The cheapest place to deal with a defect is the moment and place it's born. So what does quality at the source actually mean in practice? It comes down to 3 commitments, made by every person at every station. 1. Don't accept a defect. If something arrives at your station that isn't right, a damaged part, incomplete work, wrong information, don't quietly work around it. Flag it. Accepting it hides the problem and makes it yours. 2. Don't make a defect. Follow the standard, do your checks at the key points, and set your work up so mistakes are hard to make. We'll get to how. And 3. Don't pass one on. This is the heart of it. If you're not sure a piece is right, it stops with you. Passing on a known or suspected defect just exports the problem downstream, where it costs 10 times more. Accept none, make none, pass on none. 3 refusals. That's the whole principle. Here's a way of thinking that makes those 3 commitments feel natural. The next process is your customer. We usually think of the customer as the person who buys the finished product. But inside the plant, everyone has a customer much closer than that. The next station, the next department, the next person who receives your work. And you, in turn, are somebody's supplier. Ask yourself, would I be happy to receive what I'm about to send? Passing on a defect isn't a small internal shortcut. It's giving your customer a problem to deal with. And that works in the other direction too. As a customer, you're entitled to expect good work arriving at your station, and right to raise it when it doesn't. When every handover inside the plant is treated like a delivery to a real customer, quality at the source stops being a slogan and becomes just how work changes hands. So how do you catch problems at the source? With checks built into the work itself. Like the operator in this picture, checking the piece in her hands before it moves on. The first layer is the self-check. At defined key points in the task, you verify your own work, a dimension, an orientation, a connection made. Not a big inspection event, a few deliberate seconds built into the rhythm of the job. The second layer is the successive check, a quick look at what arrives from the previous station before you build on it. 2 layers and a defect has to slip past both to travel. But here's the real power, feedback in seconds, not weeks. If I check my own work, I catch my own error immediately, while the cause is still right in front of me. An inspector at the end of the line finds it days later, when nobody remembers why. Checks at the source aren't extra work. They're what makes the rest of the work count. The idea behind all of this has a name, Jidoka, often translated as built-in quality or automation with a human touch. It's one of the 2 pillars of the Toyota production system, and it's older than you'd think. In the 1920s, Sakichi Toyota built a loom that stopped itself the instant a thread broke. Simple, but revolutionary. It meant the loom never wove meters of defective cloth, and one operator could watch many looms because a stopped machine announced its own problem. That's the principle. When something abnormal happens, stop, because continuing means producing defects. And it applies to people just as much as machines. When you spot something wrong, you stop. You don't push on and hope. Stop, fix, or contain, then restart. A process that stops for problems produces better quality than one that runs through them, every time. If stopping is the principle, and on is the mechanism. An andon is simply a signal for help, a cord to pull, a button to press, a light that changes color, like the one this operator is reaching for. Here's how it works. You spot a problem you can't resolve in your cycle. You trigger the andon. The team leader comes to you, at your station, within moments. Most problems get contained right there while the line keeps running. The line only stops if the problem can't be resolved in time. And then that's exactly the right outcome, because the alternative was building defects. Notice what andon really is. It's the 8th waste lesson and the psychological safety lesson from earlier modules, made physical. It says, we'd rather hear about a problem in seconds than find it in inspection next week. And giving every operator the authority to call for help, even to stop production, is one of the strongest statements of trust a plant can make. Let's put the culture test for Module 4 to work right here. Stopping the line is never the failure. Passing on a defect is. In a plant where an andon pull is met with a thank you, where the leader arrives asking, what did we find? Problems get surfaced when they're small and cheap. In a plant where pulling the cord gets you a sigh or a lecture about targets, people learn fast. Keep quiet, pass it on. Let inspection catch it. Same equipment, same product, completely different quality. Quality at the source runs on psychological safety. If you lead people, how you respond to the next andon call is the quality system. And if you're on the line, the colleague who stops and raises their hand isn't slowing the team down. They're doing exactly what this entire module is asking for. Now, an uncomfortable fact, and a liberating one. Humans make errors. All of us, experienced, careful, well-trained people, pick the wrong part occasionally, skip a step under pressure, put something in backwards at the end of a long shift. Telling people to concentrate harder has never fixed this, and blame fixes it even less. You learned why in Module 4. The breakthrough is to separate 2 things we usually mix up. An error is the slip itself, grabbing the wrong screw. A defect is the outcome, the wrong screw fitted and sent downstream. Between the 2 there's a gap, and that gap is where you win. You will never eliminate every human error, but you can design the work so that an error either can't physically be made or is caught the instant it happens before it becomes a defect. That design discipline has a name: poka-yoke. Poka-yoke is Japanese for mistake-proofing. And here's the thing: you already rely on it every day without noticing. A 3-pin plug only fits the socket one way. You can't wire yourself a mistake. The microwave stops the moment you open the door. Your car won't let you start it in gear and beeps at you until the seatbelt clicks. The diesel nozzle at the pump physically doesn't fit a petrol filler. Your computer won't save a file without a name. None of these rely on you being careful. That's the genius of it. The design does the remembering, so your attention is free for the work. Nobody reads a warning poster at the fuel pump. The nozzle simply doesn't fit. Good mistake-proofing beats good intentions, every single time. So the question for us is, what does that look like on our shop floor? On the floor, poka-yoke comes in 2 strengths. The strongest is prevention. The error physically cannot be made. A fixture that only accepts the part in the correct orientation. A guide pin that makes the connector impossible to fit backwards. An interlock that won't release the next step until this one is complete. If you can prevent, prevent. The second strength is detection. The error can still happen, but it's caught instantly. A sensor that checks presence before the cycle continues. A counter that knows there should be 6 screws, not 5. A weight check that flags a missing component before the box closes. And around these sit the supporting cast you already know from Module 3. Color coding, shadow boards, clear visual standards, making the right way obvious. The best poka-yokes are usually simple, cheap, and invented by the operators who know exactly where the process bites. If you've ever thought, someone's going to get this wrong one day, you found a poka-yoke waiting to be built. So let's take stock. You're checking at the source. Problems get stopped, not passed on. The worst error traps are mistake-proofed. You've built quality in, today. Now the harder question, what about tomorrow? What happens on the night shift, when the person who found the good way isn't there? What happens when a new starter learns the job from whoever happens to be nearby? What happens in 6 months, when the clever fix has faded into memory? Improvements that live in people's heads evaporate, through rotation, turnover, and plain forgetting. Quality needs somewhere to live that isn't memory. It needs the good way captured, visible, and followed by everyone, until an even better way replaces it. That's standard work, and it's the second half of this module. Standard work is simply this: the current, best-known way to do a task. The safest, easiest way that reliably produces good quality, agreed by the people who do it, made visible, and followed by everyone who does that job. Let's take the myths head on, because the word standard makes some people bristle. A standard is not a punishment, and it's not bureaucracy for its own sake. It's the team's memory. Every lesson learned about this task, captured so nobody has to relearn it the hard way. And it's not about turning people into robots. It's the opposite. When the routine parts of the job are stable and predictable, your attention is freed for the parts that need judgment. Noticing problems, spotting improvements. Where there's no standard, every person does the task their own way. Results vary shift to shift, and nobody can say what right even looks like. The standard is where right is written down. Taiichi Ono, the father of the Toyota production system, put it in one line: without a standard, there can be no improvement. Sit with that, because it's the opposite of how most people feel about standards. Improvement means finding a way that's measurably better than the current way. But if there is no defined current way, no standard, then better than what exactly? You can't run a fair experiment against a moving target. You change something, results shift, and you have no idea whether it was your change or just the usual variation. The standard is the baseline that makes learning possible. Far from being the enemy of improvement, the standard is what improvement stands on. So think of a standard not as a cage, but as a ratchet. Here's what it does for improvement. It gives you a baseline. Every PDCA experiment from Module 4 compares the new way against the standard. That's how you know if it's actually better. It gives you stability. When everyone works the same way, variation drops, and the real problems stop hiding in the noise. It makes abnormality visible. If there's a defined normal, anything abnormal stands out immediately. If everyone works differently, nothing is ever abnormal. And it locks in the gains. Remember, standardize the gain from the culture module? When an experiment wins, the act step writes it into the standard, and the whole team improves at once. That's the ratchet. PDCA turns the wheel. The standard is the pawl that stops it slipping back. Improvement without standards slides backwards. Standards without improvement stagnate. You need both. At foundation level, a good work standard answers 3 questions. First, the steps. What is done in what sequence? The order usually matters more than people think. Many defects are really sequence errors. Second, the key points. How each critical step is done. The torque that matters, the orientation to watch, the click you should feel, the check you make before moving on. Key points are where quality and safety actually live, and where your self-checks from earlier in this module are written down. Third, the reasons. Why each key point matters. This one gets skipped, and it's a mistake. People reliably follow what they understand, and reliably drift from what seems arbitrary. Torque to spec because this joint sees vibration beats torque to spec every time. Steps, key points, reasons. There's more at practitioner level. Timing, work in progress limits, and the team leader module on training within industry goes deeper. But steps, key points, and reasons will carry you a long way. Where should a standard live? Not in a binder in an office. At the workstation, where the work happens. Like the visual instruction in this picture. A few things make the difference between a standard that works and one that gathers dust. Make it visual. A good photo with a highlighted key point beats a paragraph of text. Module 3's visual management lesson applies directly here. Keep it current. The moment the standard stops matching reality, people stop trusting all of it. So version control matters. One current version at the point of use. Make it usable in seconds. An operator glancing up mid-task should find the key point instantly. And write it with the people who do the job. In their words, a standard written about the work, without the people who do it, describes a job that doesn't exist. The test of a good standard is simple. Could a trained colleague from another area do this task correctly, first time, using only what's posted at the station? Now the part that makes standards work long-term. They're living documents, and they come with 2 duties that belong together. Duty 1. Follow the current standard. Not roughly, not my own version of it. The standard, as written. Private workarounds are how defects and accidents happen, because a workaround silently deletes a key point that was put there for a reason you may not know about. Duty 2. Challenge the standard openly. If it doesn't match reality, say so. That's a find, not a complaint. If you know a better way, propose it. Test it properly. A small PDCA experiment like Module 4 taught. And when it proves out, change the standard through the agreed process, so the whole team moves to the better way together. Follow it and challenge it. One without the other fails. Following without challenging is stagnation. Changing without the process is chaos. The people who do the work own the standard. That ownership is both duties, together. Here's where the 2 halves of this module click together. Standard work is where quality at the source lives. Look at the connections. Your self-checks. They're key points in the standard. The Poka-yoke fixture. The standard tells you how to use it and how to confirm it's working. Don't pass it on. The standard defines exactly what right means at your station, so you can tell. The andon. The standard tells you when a deviation means stop and call. Follow the standard, and you are building quality in. That's what the standard is for. And it cuts the other way too. Skipping a step in the standard isn't a shortcut. It's removing a safeguard that someone, somewhere, learned the hard way. Quality at the source gives you the commitments. Standard work gives you the method that makes them keepable. Every cycle, every shift. Let's connect this to the improvement cycle you already know. There are really 2 wheels turning. PDCA, plan, do, check, act, is the improvement wheel. It climbs the hill, finding better ways. SDCA, standardize, do, check, act, is the stability wheel. It holds the ground you've won. Standardize. The best known way is defined and taught. Do. Work to the standard. Check. Is it being followed? And is it still producing good results? Act. If not, respond. Retrain, fix the standard, or escalate the problem it revealed. The 2 alternate, and that's the rhythm of a healthy operation. Stabilize, improve, stabilize at the new level, improve again. All PDCA and no SDCA, and your gains evaporate behind you. All SDCA and no PDCA, and you're perfectly stable and standing still. The ratchet needs both the wheel and the pawl. Let's run the whole module through one small story. A connector at an assembly bench can be fitted 2 ways, and the wrong way has now escaped twice this month. Watch the loop. Catch. The next station's successive check spots the third one. It goes no further. The operator flags it straight away. Stop. The team leader responds to the andon call. The batch at the bench is checked the same shift, while the trail is warm. Understand. The team looks at the error, not the person. The part is symmetrical, so on a long shift, anyone could fit it backwards. Classic error trap. Error proof. A guide pin is added to the fixture. The connector now only fits the correct way. Total cost, 1 pin. Standardize. The standard is updated. New photo, new key point, and the change is shared at the next huddle. Now the fix belongs to every shift, including people who never saw the defect. 1 loop. Caught at the source, stopped, understood, error-proofed, standardized. That's this entire module in 5 moves. A quick modern note before we close, because these 100-year-old ideas are getting sharp new tools. Digital work instructions put the standard on a screen at the station. Photos, short video clips, always the current version, updated everywhere at once. Vision systems and smart sensors now do inline checks on every single piece, not a sample. A camera that verifies the connector's orientation is a successive check running at machine speed. And andon systems send the call for help straight to the team leader's device, with the response time tracked. But notice what none of this changes: the thinking. Build it right the first time. Stop when something's wrong. Capture the best way and improve it. The technology just runs the same old discipline faster and wider. A camera can catch a defect. It still takes a person to ask why it happened and make sure it can't happen again. So here's your part. 6 things to practice this week, and none of them need permission or a project. Do your self-check deliberately, every key point, every time, not on autopilot. Never pass one on. If you're not sure a piece is right, it stops with you. That's a decision you're allowed to make. Raise your hand early. Flag problems in seconds, not at the end of the shift. Small and fresh beats big and cold. Spot one error trap. Find something in your work that would be easy to get wrong one day, and suggest a way to make it impossible. Compare the standard to reality. If what's posted isn't how the job is actually done, say so. That's a find. Either way it settles. And propose one improvement. If you know a better way, offer it for a proper test. 6 behaviors. Every one of them is quality at the source, happening. Let's bring the module together. Quality is made at the source, at the workstation, by the person doing the work. Inspection at the end just finds failures, at 10 or 100 times the cost. 3 commitments. Accept none, make none, pass on none. The next process is your customer. Stop and fix. Jidoka builds quality in, and Dawn calls help in seconds, and stopping the line is never the failure. Errors aren't defects, yet. Good people slip, so design the work with poka-yoke to prevent errors or catch them instantly. No standard, no improvement. The standard is the baseline that makes experiments meaningful and the ratchet that holds every gain. And standards live. Follow the current one, challenge it openly, improve it through the process, owned by the people who do the work. Build it right the first time, and make the right way the easiest way. So, before you go, build it right the first time and make the right way the easiest way. You don't need a title for any of this. Check your own work like the next station is your customer, because they are. Stop when something's wrong and thank the person next to you when they do the same. Respect the standard and never stop improving it. That's quality at the source, not a department, not a system. A decision each of us makes, piece by piece, shift by shift. Thanks for joining me for this module. Next, in F6, we complete the foundation tier with safety, ergonomics, and sustainability in CI. How improvement protects people and the planet, not just the numbers. I'll see you there.